Alright, here are our notes for solving and checking equations. The first thing I want to mention is the word equations. I want you to think what word is in the word equations. And I want you to notice the word equal is part of equations. So when we talk about solving and checking equations, we are talking about number sentences with an equal sign. You're going to notice in the first step there will not be an equal sign, but throughout the entire notes you will see that we are solving and checking equations. So, steps to solving equations. Step 1 is to distribute the parentheses. Whenever we see a parentheses, our job is to take the number and the sign, whether there's a number or not, meaning that there's an invisible 1, or if there is just a sign, we are going to distribute that to the different terms that are in the parentheses. So I'm going to show you what a term is right now. Oh, need a bigger highlighter. Here's a term. Okay, and terms are separated by a plus or minus sign. So what we're going to do is we're going to take, well, I don't have my stylus on me. We are going to take this negative and we are going to go ahead and distribute it into the two different terms inside the parentheses, kind of like what we've been doing with flipping tiles. So we have 3x, and what we're going to do is we are going to distribute the negative into 5x plus 2. So negative 1 technically times 5x is minus 5x, and a negative 1 times positive 2 is minus 2. So what we just did right now was distribute the negative into the two different terms, 5x plus 2. Ooh, here's another example. If I can move the screen. 9 minus 7, and in parentheses we have x minus 4. What we need to do here is distribute the negative 7 into x and minus 4. So we're going to keep the 9, and this negative 7 is going to be distributed, multiplied by both 7 and negative 4. So here, negative 7 times x is negative 7x. Negative 7 times negative 4. A negative times a negative, if we remember our little diagram, when we multiply positive and negative integers, we know that a negative 7 times a negative 4, go ahead and cover those two up, right? If I covered these two up, oh, nope, not that. I'm going to erase the two negatives. What am I left with? That's right, a positive. So we are going to have plus, and 7 times 4 is 28. Okay. The last problem we have here, or example, is 2, and then parentheses 9x plus 1. What we're going to do is we're going to distribute the 2 into 9x and 1. 2 times the 9x is 18x, and 2 times 1 is positive 2. We have now distributed their parentheses. That is the first step. Step 2, combine like terms. on each side if possible. So what I'd like you to do every time is to draw two lines just representing an equal sign, and now we know that when we're talking about on each side, we're talking about each side of the equal sign. So what we're going to do is highlight like terms. So we have 3x minus 17x and plus 8. On the right side, we have 5x and then 3 plus 11. That's a lot better. Okay? And what we're going to do right now is we're going to combine 3x minus 17x. That gets us negative 14x. And then we've combined those two. Now we have to combine 8, but there's nothing to combine it with, so we can keep it as 8. On the other side of the equal sign, we can combine the units, but there's nothing to combine 5x with, so we're going to keep 5x plus 11 plus 3 is 14. That's the second step we are going to do. So first we are going to distribute. If they're parentheses, second we are going to combine like terms. Now, after you have combined like terms, our third step is to get the variables on one side. Now, if we have variables on both sides of the equation, we are going to remove the variable on one side. And a key to this is we want to try to get rid, okay, of the smaller group of variables. So if we look at our first example, we have 4x plus 15 equals 6x minus 19. And we want to remove the variables on one side. So we are going to look and see which one has a greater value, 4x or 6x. And hopefully you know that 4x is smaller, so we're going to say that 6x is larger. And what we're going to do is we're going to remove the smaller group of variables. So we know that 4x is smaller. We're going to subtract 4x from both sides. Now, I want you to think why we would remove 4x instead of 6x. I want you to think, why would we remove 4x instead of 6x? Well, hopefully you notice that if you subtract 4x from both sides, let's not do that. If we subtract 4x from both sides, we are going to end up with a positive 2x. Here the 15 just drops down. We'll end up with 2x minus 19. Now if we subtracted 6x from both sides, we're going to end up with a negative x, and that's not something that we would want. So the reason why we are trying to get rid of the smaller group of variables is so that we have a positive, or we are adding. That's going to happen here and there where we have a negative x, even if we get rid of the smaller group of variables, but that's okay. So here, another example. We are looking at the x's, or the variables. They are on both sides, so we want to get rid of the smaller valued variable. And we want to compare x and negative 7x. And I want you to think, which one has a smaller value? Right, sweet. Hopefully you notice that negative 7 is a smaller value. So what we're going to do is we're going to get rid of the variables on that side, which means we have to do the inverse operation, or the opposite of. So if it's minus 7x, we need to add 7x to both sides. Okay? Once we add 7x to both sides, we will have 21 on the right side and 8x plus 5 on the other. Okay? Now, after we've gotten the variables on one side, we are going to get the units on the other side. So if there are units next to the variable, get rid of the units next to the x's or the variable. So here, example number 1, 17 equals 4x plus 5. I want you to notice that there are units next to the variable. We want to get rid of those units. So we are going to draw our equal sign and subtract 5 from both sides so that we can get rid of plus 5. And we are going to end up with 4x equals 12. Okay, so we're doing the opposite of step 3 basically. In step 3 we get the variable and we remove it from one side, and then in step 4 we're going to take the units or just the numbers and get them on the other side of the x. Okay, here we have negative 3 plus 6x, so we want to notice that this is next to the x's or next to the variables. Okay, and what we want to do is we want to take the inverse operation. So it says negative 3, we want to do positive 3. And what's going to happen is negative 3 plus 3 is going to be 0 plus 6x. So now we have 6x equals negative 15 plus 3 is a negative 12. Okay. So that's step 4. Step 5 is to divide by the number in front of the x, and that number is called the coefficient. It might be weird for you, but I would like you to say the word coefficient because it's a vocabulary word that is new. Coefficient. And the coefficient is the number in front of the x. So what we're going to do here is we're going to divide by the coefficient of x, which is 6, on both sides. And 6 divided by 6 is 1, so we have 1x equals 48 divided by 6 is 8. So 1x equals 8. And I'll use the 1 to create a box. Example number 2. We have negative 45 equals 9y. We are going to divide by the number in front of the x, which is also known as the coefficient. We are going to divide both sides by 9. And negative 45 divided by 9 is negative 5. And 9 divided by 9 is y. So y equals negative 5. Last problem here. We're going to divide by the coefficient, which is negative 4. Negative 4. And negative 4 divided by negative 4 is 1. So we have x equals, and 22, 4 does not go into 22 evenly. So we're going to go ahead and draw this out, or write it out. 4 divided by, 22 divided by 4. 4 does not go into 2. 4 doesn't go into 2, so we're going to subtract 0. Drop down 2. 4 goes into 22 5 times, minus 20. Now we have a decimal here, decimal, and after decimal we have an infinite amount of zeros. We could drop down to 0. 4 goes into 25 times, evenly. We have no remainder, so our answer here is 5.5. Okay. Alright, so just a quick overview. Our steps to solving an equation. We have 1. Distribute. 2. Combine like terms. 3. Get the variables on one side. 4. Get the units on the other. And 5. Divide. So we're going to take this example right here, number 1. It's quite a long problem, but we are going to go ahead and give it a shot. So here it is. First step, we need to distribute. So go ahead and write distribute. Distribute. Okay, so that means we're going to look for the parentheses. I'm going to go ahead and circle the term in front of it. It's a negative, so it's like opposite land. We have the opposite of 9x and positive 3. I'm going to go ahead and copy. Here, let me actually change all of this to red. Change this on to red, just so you can see what's happening. So we're going to distribute, copy the rest of the problem in black, and show you what's happening. 7 minus 6x, that doesn't change, equals 5x. Here we are distributing, so we're going to have negative 9x minus 3. Or you could think of opposite land, and we're flipping the tiles. Okay. After that, step 2 is to, let's choose a darker color, C, combine like terms. Okay. So what we need to do is we need to highlight. Highlight. One second, let me redo that. Sorry about that, just, straightening that out. Okay, so we're going to combine like terms. On the left side, actually, there's nothing to combine because we can't combine 7 with negative 6x. So we're going to keep that the same, but on the right side, we can combine 5x minus 9x, and then we will have to keep that negative 3. So on the left, nothing changed, 7 minus 6x, but on the right, we can combine 5x minus 9x, which gets us negative 4x minus 3. So what we did here is we combined these two and got negative 4x. All right, our next step, choose red. Oh, we already used red. Let's use purple. Is to get the variables on one side. Now remember, we want to get rid of the smaller group of variables. So I'm going to write that. Get rid, let me zoom in, of smaller group of variables. Alright. So what we're going to do is find out which one is a smaller group of variables. Is negative 6x a smaller value or negative 4? Alright. Well, even though negative 4... Sorry. Even if you think negative 6 is... Negative 4 is a smaller value because 4 is small, we need to notice that we're comparing negative 6 and negative 4. And hopefully you would rather have $4 you owe to the library instead of $6. Okay, so negative 6 is a smaller value. So what we're going to do is we're going to add 6x to both sides. Okay. What's going to happen here is we got rid of the variables on the left and we added 6 to the right, which will end up with 2x, and the rest will remain the same. The 7 stays, minus 3. Okay, so now we got the variables on one side. Next we want to get the units. Alright, so we want to get units on the other side. So we want to get the units on the other side of the variables. So here we have negative 3 or minus 3 next to the variables. We want to take the inverse operation. The opposite of subtraction is addition. So we're going to add 3. But if we do that to one side, we need to do it to both. This will cancel out. And this will become 10. The other side will be 2x. Alright. Last step here is, let's choose orange. Divide by the coefficient. And remember, the coefficient is the number in front of the variable. So we're going to divide both sides by 2. And our final answer is x equals 5. Okay. That is how you solve an equation. You first distribute, then combine like terms, get the variables on one side, the units on the other, and then you divide. Okay, now what were we doing this whole time? We were trying to solve for a value for x to make this equation right here true. Okay, we're trying to solve for x to see, we're trying to see what x equals to make this equation right here true. Now, if x equals 5, what we should be able to do to check our answer is to put the answer we found for x, so plug in your answer in place of x, and we should be able to check if the statement is true, right? If I solved for this equation and I said x equals 100, even though it's not, because x equals 5, as you can see, we solved, got x equals 5, we should be able to take our answer and plug it in place of x in the original equation. Okay, so if we go ahead and put 5 in for x, and I want you to notice that this problem right here and this problem right here are identical, except the fact that the x values are replaced with 5. Okay. Go ahead and take a look. You can see what we did was we plugged in our answer that we got in place of x. And what we should be able to do is take this and solve or simplify, okay, following the rules of PEMDAS or the order of operations, okay, and this should come out to be equal. So PEMDAS, okay, PEMDAS is parentheses exponents multiplication division then addition and subtraction. Okay. If we first do these parentheses first in exponents, then multiplication and division, then last add and subtract. So we're going to look across and see, are there anything in parentheses? And yes, there is right here. So what I'm going to do is I'm going to copy the problem just like it is, except I am going to solve inside this parentheses. Okay. Now 9 times 5 is 45 plus 3. I still need to work this out in the parentheses, so I'm going to copy this again. And inside this is still 48. All I did so far was solve for what's in the parentheses right here. Okay. Next, I need to multiply and divide. There's a lot to multiply and divide. So 7 minus, here's a multiplication, 6 times 5 is 30. 5 times 5 is 25. And I'll copy the rest. Now that we did all of our multiplication and division, we could add and subtract. 7 minus 30 is negative 23. And 25 minus 48 is negative 23. What we did right here, ladies and gentlemen, is check our answers. Okay. So here are a couple problems we're going to do. I'm going to go through them pretty quickly, so follow along. Here, I'll copy this problem. I'll cut this, move it over here. Okay. All right. First thing I need to do is parentheses. I apologize. Distribute our parentheses. So we're going to distribute our 8. 8 times 2 is 16. Minus 8 times negative x is negative 8x. Okay. Plus 9. What we can do is draw our equal sign. Equals 37 minus 5x minus 3x. So after we distribute, we can combine like terms. Okay. So we have negative 8x plus 25. On this side we have negative 8x plus 37. Alright, well, when we see this, we're going to keep going. Now, you might notice that we have negative 8x and negative 8x. They are the same, so we don't know Well, neither of them is a smaller value. They're both equal. There isn't one that's greater, so we're going to add a x to both sides, right? Because our next step is to get the variables on one side. Well, what we just did was we have no more x, right? So we end up with 25 equals 37. And that statement is not true. And when we have a situation like this, we're going to say that there's no solution. Okay? We'll go into more detail later, but that is a situation that can happen, that there's no solution. There's no value for x that will make this solution true. Okay? Alright. Here's another example. Cut that, move it over here, let's draw a little line so we know it's a different problem. Okay, there. First thing we need to do is distribute. So we have 33 plus 10x. 5 times 2x is 10x. 5 times 9 is plus 45 equals 8. Let's combine like terms. We can combine 33 and 45. So 10x plus 8, 7 equals 8. Now we're trying to get the units on the other side, so minus 78. This is what happens when you don't draw your equal sign early. Oops. Minus 78. Minus 78. 10x equals negative 70. Divide by 10. Divide by 10, because that's the coefficient. X equals negative 7. Alright. Sorry, I am going really fast, but it is 11:20 right now, and I'm ready for bed on a Friday night. So, here we go, last one. 7x minus 6x plus 4 equals negative 19 plus x minus 5. Let's draw a little line so we know. Okay. First things first. Distribute. Okay. 7x. Negative 6 plus times x is negative 6x. Negative 6 times positive 4 is negative 24. Am I right? Am I going crazy? No, that's right. Okay. Equals negative 19 minus plus x minus 5. Okay. Next, we need to combine like terms. 7x minus 6x. Then we can combine negative 19 minus 5. 7x minus 6x is 1x, so x minus 24 equals x minus 24. Okay. Here, if we add 24, we want to get x on one side, so you'll notice that there's no smaller value, so let's just subtract x from both sides. We're going to get negative 24 equals negative 24. Now, unlike example number 2, where there's no solution, if you end up with negative 24 equals negative 24, a number equaling another number, we can say that there's an infinite amount of solutions. Oh my, I'm going crazy right now. Infinite number of solutions. What we're saying here is no matter what we put in for x, this statement's going to be true. If I say that x is 5, this is going to be true. If we say that x is 1 million, this statement's going to be true. You can go ahead and check it out, check the work, test it, put a number in, and it should come out to be equal. Well, here it is. That's our notes.